Welcome back to the deep dive. I'm genuinely excited about what we're getting into today. Sometimes the best way to really understand these big foundational ideas is to look at them, well, maybe from a slightly different angle. Today, we're doing just that. We're pulling out some absolutely essential nuggets from material that's, often used for the AWS CLF-C02 foundational exam prep.
That's exactly right. And while, yes, the source is geared towards certification, the actual insights, they're incredibly valuable for anyone touching the cloud. Doesn't matter if you're aiming for the exam or not. These aren't just test questions. They're like little windows into how AWS fundamentally works and how you can use it well.
Totally agree. I mean, the CLF-CO2 itself, it's foundational, right? 90 minutes, 65 questions, multiple choice, multiple response. Needs 700 out of 1,000 to pass. But for us, that's just the jumping off point. Our goal today is to pull out the really critical stuff, the practical bits, maybe things people overlook from these core concepts. We want to make them super clear, memorable, and frankly useful for your understanding of cloud computing.
Think of it like a shortcut, not just to facts, but to really being, well, properly informed about some of the absolute bedrock pieces of the AWS world.
Okay, let's dive in. Our first insight comes from a real cornerstone, the AWS shared responsibility model. A typical question might be something like, according to the AWS shared responsibility model, what's the customer responsible for? You might see options about AWS handling physical security or the global infrastructure. But the correct answer and our key takeaway here is something like patching the guest operating system on an EC2 instance.
Oh, absolutely foundational. And, it's often where confusion starts. This model is key for cloud security. AWS takes care of security of the cloud. Think physical data centers, the network connecting them, the hardware running everything, the hypervisor layer, that base infrastructure.
So they secure the building, the power, the servers themselves.
Exactly. But you, the customer, you're responsible for security in the cloud. And that covers a lot. Your data, obviously, your applications, and crucially, the operating systems you choose to run on services like EC2. That includes installing updates, security patches, keeping that guest OS safe from vulnerabilities.
Right. So AWS provides the secure warehouse, but you're responsible for the locks on your storage unit inside and what you put in it. It's a really vital distinction, isn't it?
It is, and it's where people can get tripped up. They might think, it's cloud, AWS handles everything. But for infrastructure as a service like EC2, no. You own that OS layer upwards. Your configurations, your firewall rules, your application security, and yes, patching.
Got it. That clarity is essential. Okay, next up. Smart traffic management. Let's imagine a company. They've got a web app. It's running on several EC2 instances, pretty standard stuff. They need to distribute incoming web traffic, HTTP and HTTPS, but they also need to route it cleverly, like send traffic for images to one set of servers and a TEPI to another based on the content of the request. Which AWS service is built for that kind of intelligent Layer 7 routing?
This is where it gets interesting. The answer is the Application Load Balancer, or ALB.
The ALB is incredibly powerful for exactly this kind of scenario. It operates at layer 7, the application layer. That means it can actually look inside the HTTP, HTTPS requests. It understands things like host headers and URL paths. So like you said, a request for www.yourwebsite.com images, the ALB can send that to a specific target group of instances. But a request for www.yourwebsite.com, ABIW, EPSNAS, APTUM, that can go to a completely different group, maybe scaled differently, optimized for API calls. It's smart routing.
Okay, so it's not just spreading the load, it's directing traffic based on what the user is actually asking for. How does that compare to other options, like, say, a network load balancer?
Good question. A network load balancer, or NLB, is super fast, really high performance, but it works at layer 4, the transport layer. It mainly deals with TCP and UDP connections. It doesn't look inside the application data like HTTP headers. Great for raw speed, less so for content-based decisions.
And the old classic load balancer.
That's legacy now, really. The ALB and NLB offer much more functionality and better performance. Classic is still around, but not recommended for new stuff. And then there's AWS Global Accelerator, which is different again. It helps with global latency, directing users to the nearest AWS edge location. But it doesn't do the specific back-end routing based on content like the ALB does within a region.
So for modern web apps needing that intelligent, content-aware distribution, the ALB is really the go-to workhorse.
Definitely. It enables things like microservices architectures where different services handle different paths, all behind one ALB.
Okay, let's switch gears a bit. Auditing and security logging. Imagine a company needs a complete record. They need to continuously monitor and log every single API call made across their AWS accounts. Who did what, when, from where. Vital stuff for audits, security analysis, compliance. What's the AWS service that provides this comprehensive audit trail? The answer here is AWS Cloud Trail.
CloudTrail is essentially the mandatory logging service for AWS. It's your definitive record. It captures pretty much every API action, whether it's someone clicking in the console, a script running using the CLI or SDK, or even AWS services acting on your behalf. It records the caller identity, the time, the source IP, the request parameters, the response elements, everything you need for forensics or compliance.
It's like the security camera footage for your entire AWS environment, recording every single interaction.
That's a good analogy, yeah. It provides that historical record.
Yeah.
It's important to distinguish it from other security services, though. Like Amazon Guard Duty is about threat detection. It analyzes CloudTrail logs and other data sources to find suspicious activity. AWS Config tracks resource configuration changes and compliance. Amazon Inspector looks for vulnerabilities within your instances or containers.
Right, so Guard Duty finds the bad guys, Config checks if things are set up right, Inspector finds software flaws. But CloudTrail is the fundamental record of every action taken.
Precisely. CloudTrail provides the raw data, the evidence trail that many other services might consume, but its core job is that comprehensive, immutable logging of API calls. It's indispensable for accountability.
Absolutely critical. Okay, let's talk about architecture. Building for resilience. What are the key design principles you should follow on AWS to build something reliable, something that can handle failures? This often comes up as a select two kind of question, with bad options like use single points of failure or build tightly coupled systems. Definitely not those. The two core principles we're looking for are automate recovery from failure and test recovery procedures by simulating failure.
Yes, these two really capture the modern cloud philosophy for reliability.
Huh?
You have to assume things will eventually fail. Hardware breaks, networks get flaky, software has bugs. So, principle one, automate recovery. Design your system so it can detect a failure and recover automatically without needing a human to jump in. Think auto-scaling, replacing a failed instance, or using multiple availability zones so if one goes down, traffic automatically routes to another. Minimize that manual intervention during a crisis.
Right. Build self-healing capabilities into the system itself. Don't rely on someone getting paged at 3 a.m.
Exactly. And principle two, test recovery procedures. Don't just assume your automated recovery works. You need to test it. This is where things like chaos engineering come in. Intentionally break things in a controlled way. Terminate an instance, block some network traffic, inject latency, and see if your system recovers as expected. Regular testing builds confidence that your resilience plans actually work under pressure.
So it's about being proactive, right? Expecting failures, building systems that handle them automatically, and then proving that they work through testing. It's the opposite of just hoping for the best or having everything depend on one critical, fragile component.
Absolutely. It's about designing for resilience from the ground up, embracing the dynamic nature of the cloud, and building systems that can gracefully handle disruptions.
Okay, final insight for today. Secure access management. This is huge. Let's say a sysadmin needs an application running on an EC2 instance to be able to talk to an S3 bucket. Read or write files, perhaps? The critical rule is no hard-coding AWS credentials, access keys, secret keys into the application, or storing them on the instance. That's a massive security no-no. What's the most secure, recommended way to grant these permissions? The solution is assigning an IAM role to the EC2 instance.
IAM roles are, well, they're the standard, the absolute best practice for this. They are a game changer for security in AWS. Instead of creating static, long-lived credentials for an application or user, you create a role. This role defines a set of permissions like allow access to this specific S3 bucket. Then you attach that role to the EC2 instance. AWS securely provides temporary credentials associated with that role directly to the instance, typically via its metadata service.
Temporary credentials, so they expire.
Exactly. They're short-lived and automatically rotated by AWS. The application running on the instance just uses the AWS SDK, which knows how to automatically fetch and use these temporary credentials. There are no static keys stored in config files or environment variables for an attacker to find.
Okay. So it completely avoids the risk of those permanent keys getting leaked or compromised. How does that compare to, say, encrypting the keys and storing them on the instance?
Still risky. If someone gains access to the instance and can decrypt the file, they get the keys. Using an IAM user's keys directly is also bad practice for applications. IAM roles are designed specifically for this service-to-service or service-to-resource interaction. They embody the principle of least privilege, granting only necessary permissions, and combine it with temporary, automatically managed credentials. It's far more secure.
That makes perfect sense. Dynamic, temporary, managed access instead of static, risky secrets.
Precisely. It's fundamental to secure operations in AWS. So maybe here's something to think about, building on that last point. We talked about IAM roles for EC2, emphasizing those temporary, automatically managed credentials over static keys. Thinking about that core principle, short-lived, context-specific, managed access area. How might that idea change the way you approach security and access management in other systems you work with, maybe even outside of AWS entirely? What could the future of identity look like if we move away from static secrets everywhere?
That is a great question to chew on. Really makes you think about credential management differently. Thank you so much for joining us on the deep dive today, and we look forward to exploring more with you next time.